Hello, eighth period math friends. Mr. Thompson here, sending another video to you. Today, I want to talk about fractions. Okay, I know that we've been converting fractions into whole numbers in order to solve expressions. But when I was bringing up fractions earlier in the week, something came to my mind, which is simplifying fractions. That's something that I know that we practiced maybe just a little bit before we went into our break. Um, but it definitely is something that is not going to go away. Okay, so when we go into our eighth grade year, we're definitely going to be simplifying fractions, and as well as we go into high school. So it's definitely a tool that you guys are going to want to continue learning and continue practicing. With that being said, there's kind of a neat tool that I want to show you guys, a neat way that you can solve fractions or simplify fractions when asked to do so. So the more common way that you hear of people doing is that they'll find a common multiple and multiply by that and then break it down from there. But the way I'm going to show you, and I'm going to share my screen with you here right now, is a way that honestly I hadn't done before, but it's a way that I've learned to do, and it's I think a way that is, in my opinion, a little bit more simpler. So I'll let you guys be the determining factor with that. If you enjoy it, good. If you don't enjoy it, you can go and do the original way that we've been doing, or that you've done in the previous years. Okay. So I'm just going to start off. So I'll write a fraction. Okay. So I'm going to write, and I'll write a little bit bigger for you. Say I write 12 over 15. Okay. 12 over 15. So 12 over 15 is obviously a fraction. It also could be described as being 12 divided by 15. That'd be the same thing. So if you're asked to simplify this fraction, what you could do is break it down from the numerator to the denominator in smaller portions. Okay, so for instance, we have 12 here. We know with 12, it is 4 times 3. Likewise, looking down at 15, we know that 15 is 5 times 3. So this, you're multiplying 4 by 3 to get 12. You're multiplying 15 by 3 to get, 5 by 3 to get 15. So now what we do is we cancel. So just like we were finding, or we were doing canceling zeros, or finding, creating zero pairs. Sorry, it wasn't coming to my mind right away. You're doing the same thing here. Is you're going to want to cancel the 3's, because both of these would cancel. And what you're left with would be the simplest form that this fraction could be in, which is 4/5. Now, because it's in simplest form, does not mean that this, what's the word I'm looking for? The 12 over 15 and 4 over 5 is the exact same amount. Okay, they equal each other. But what you're doing is you're taking 12/15 and you're putting it in the simplest form, which is 4/5. So 12/15 is in simplest form 4/5. Okay, I hope that makes sense. If not, maybe I'll be able to explain it a little bit better as I go on to our second example here. Okay, so we're going to go ahead and erase this. And let's just practice again with a different one. So let's do 12 again over 28. Now, it is important that you guys know those multiplication facts when you're going through this. It makes it, I think, a lot easier to answer, to solve. So when we look up here, 4 times 3 gives us 12. And 4 times 7 gives us 28. Okay, same thing that we did before. We're going to go ahead and cancel our 4's. That's our zero pair. And what we're left with is the simplest form of 12 over 28, which is 3/7. Okay, let's go ahead and practice this again. Let's see, I think I have another one. Okay, let's do a big one. So 54 over 30. Okay, so 54 is 9 times 6, where 30 is 5 times 6. We have both 6's here, so we can go ahead and cancel. What we're left with is 9/5, which is the exact same thing as 54/30. It's just in simplest form, it's 9/5. Okay, now the question might come out, well, what about in terms of variables? Okay, because I know that we've seen a couple examples, like for instance, let's look at it like this. If we did, let's do x to the 4th over x. Okay, we've seen examples like this. Well, once again, we're going to do the same thing that we did with our whole numbers, but instead, looking at x to the 4th, it would be x times x times x times x. Okay, you're multiplying x 4 times, or x to the 4th. Down here, we have just one x. We're going to go ahead and cancel, just like you would have canceled with your whole numbers. And what you're left with is x times x times x, or x cubed. If you want to put a place value underneath it, it'd be over 1, or you could just leave it as x cubed. Okay, and let's do one more example with a variable. Let me see what I got. Let's do this time x squared over x to the 5th. Make it a little bit bigger. Okay, this is the same thing as saying x times x. Well, here we've got 5 of them, so x times x times x times x times x. Okay, so we have 2 x's on the top. We have 5 x's on the bottom. So what you're going to do is we're going to cancel our x's. And we kind of did this with our tiles, with our algebraic tiles that we used. Kind of the same similar thing where you're canceling or creating those 0 pairs with these x's. So now what you're left with is, and the denominator, x cubed. Where on the top, you can go ahead and put that place value of 1 to hold that x cubed, okay? Go ahead and cancel out of this here. Okay, so we went through and just did a kind of a quick video on how do you simplify fractions. And this was a tool that I found to be helpful for me. I hope it's helpful for you. As we move forward, it's going to be something that you can definitely use. If you have another way that you like to go about doing it, obviously I don't want to disrupt that, but I also want to make sure that we're doing things in a way that is most simple for you, okay? I will be sharing some videos later on in the week, and I hope you guys have a wonderful day. As always, please reach out with any questions or concerns that you might have. Thanks.